Welcome to section 8.4b. There are not any new definitions or new key ideas in this section. However, it will give us an opportunity to compare data sets, and that is it's a topic that's new to 7th grade. So section is important for practice purposes. In number 1, it says that you want to know if students at a school are in favor of building a new computer lab. You conduct 2 surveys. For survey 1, you randomly ask 70 students in the hallways before homeroom. For survey 2, you randomly ask 70 academic club members. There are 1,400 students in the school. Okay? And then, of course, these are the responses from the 2 surveys. In part A, use the results of each survey to predict the number N of students in the school that are in favor of building a new computer lab. Okay, so we're going to do the process 2 times, once for survey 1 and once again for survey 2. So for survey 1, we noticed that 21 respondents answered yes. And how many people did we ask in survey 1? We randomly asked 70 students. So responses in survey 1, we had 21 out of 70 yes answers. And we're asked to predict the number N of students in the school that are in favor of building the computer lab. So we can set up a proportion where we do a part over a whole, and then we don't know how many students are in favor, but we know that there are 1,400 total students in the school. So we're going to say N over 1,400. And N will tell us the number of students in the whole school who are in favor of the computer lab. You can tell this textbook is kind of old because computer labs are seem kind of dated now in some ways. Maybe not. So we've got a proportion we want to cross multiply. So 21 times 1,400 gives us 29,400 equals 70 times N. Then I need to divide both sides by 70 to get N by itself. 29,400 divided by 70 gives me 420 equal N. So 420 students for survey 1. Squeeze my units in there. Survey 2, I'm going to do the same process. So in survey 2, 34 students answered yes. And in survey 2, 70 academic club members were chosen. So it's 34 out of 70. And then again, N is the number of students in the school who are in favor. And we want to set that up over 1,400 students from the entire school. So again, we've got the part over the whole equals the part over the whole. And we're going to cross multiply. 34 times 1,400. 47,600. So we've got 70 N equals 47,600. And then divide both sides by 70 again. And we have N equals 680. So 680 students. So the 2 different surveys gave us very different results. In survey 1, we found 420 students in favor of the computer lab in the entire school. Survey 2, we found 680 students in the entire school in favor of the computer lab. Part B, which prediction is more reliable? And explain. Okay, so go back and look at how they did this. In survey 1, 70 students in the hallways before homeroom were chosen for a sample. Survey 2, 70 academic club members were chosen for a sample. Okay, so one of these is more representative of the population than the other. Because the population is an entire school, then the 70 students chosen in the hallway before homeroom would be more representative of the school than choosing academic club members, because they are more likely to want a computer lab. So we're going to say survey 2 is more reliable because academic club members are more likely to want a computer lab. Okay. Oh, I'm sorry. Alright, this is what I wrote. Part B, survey 2 is more reliable because academic club members are more likely to want a computer lab. Again, I will scan this and include it in Schoology along with the video. Alright, and let's go on to the next page. Okay, I had to do, so looking at number 2, alright, so this one makes a reference to box and whisker plots. So I'm assuming you did that in 6th grade. Just in case you've never seen that, there is a video posted in Schoology of another person, not me, explaining how this is done. It's done in a very simple way with just a small number of data values. So if you're not comfortable with the box and whisker plot, I highly recommend that you watch that video before you continue with this page. Okay, so for number 2, the double box and whisker plot shows the shoe sizes of random samples of high school students. Compare the shoe sizes of girls to the shoe sizes of boys. Okay, so if we look at the boys, notice how, the first thing that I noticed looking at this is that the girls are mostly smaller than this. Notice how they kind of come together right here. So I want to look at this. The shoe size 8 is something that I want to pay close attention to. I see most of the girls have a shoe size smaller than 8, and most of the boys seem to have a shoe size larger than 8. So if you remember from box and whisker plots, if you look at, let's say we just look at the girls, remember this is the smallest number and the largest number in the data set. And then the 3 bars are the quartiles. So this bar is the first quartile, this is the second quartile, which is also the median, and then this is the third quartile for the girls. So looking at this, I can see that the third quartile for the girls is 8, and that means that 75% of girls have a shoe size 8 or smaller. Okay, so I'm going to write that down. 75% of girls have a shoe size of 8 or smaller. Okay? Looking at the boys' data, this bar is the first quartile. So remember, the first quartile is going to represent 25% of your data. So in the boys, the first quartile is 8, so that means that 25% of boys have a shoe size 8 or smaller. And again, if you don't understand what I'm saying when I talk about quartiles, you need to go back and watch the video that I mentioned. Okay? So 75% of girls have a shoe size of 8 or smaller, 25% of boys have a shoe size of 8 or smaller. So you can kind of generalize from this that we'll say in general, boys have larger shoe sizes. Than girls. Okay, so that's number 2. And then for number 3, alright, so in number 3, it says, each table shows a random sample of project grades in a class. Create a double box and whisker plot of the data. Compare the 2 data sets. So we have Miss Arnold's class and Miss, not sure how to pronounce that, Pisger's class. Okay, so the first thing that needs to be done to create the box and whisker plots is that the data all have to be listed out in order. So I went ahead and did that already to save on time. So the blue is Arnold's class, the purple is Pisger's class. I put them all in order so that I could identify my median pretty easily. So they have 20 data values, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so between 10 and 11, and I take the mean because this is this data set has an even number of data values in it. I find the median by taking the middle two and then finding the mean, or adding 79 plus 79 divided by 2, but the median is 79. So the median for Arnold's class is 79. Okay, so that would be my second quartile. So I can locate 79 on the number line that I've drawn down here. So locate 70, so I just counted by fives. Locate 79 and put a vertical bar. And then I need to find the first quartile. So that's going to be the median of just the first half of the data set. So 1, 2, 3, 4, 5. So between the fifth and the sixth data value, I would take the mean of these two and I would get 76. So my quartile 1 is 76. So I can put a bar there, vertical bar at 76. And then I need to find quartile 3. So I'm going to go 1, 2, 3. So I'm finding the midpoint of the second half of my data set. So that's the boundary there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5. Between 5 and 6 would be 84.5. Quarter 3 is 84.5. So I'll draw that in right here. And I'll put a box, make that into a box. And the lowest value of 68 goes on, I plot that as a dot. And I draw a whisker. And my largest value, 90, I locate that one, put a dot, and draw a whisker. Okay, so that was Arnold's class in blue. Now we'll do the same for Pisger's class. So for this group, the median, we've got to find it. So I'm going to go to the halfway mark. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Between 10 and 11. And divide, so take the mean of 85 and 85, and the mean is 85. So we'll put a vertical bar at 85. Then we need our first quartile. So we're going to find the median of the first half of the data. 1, 2, 3, 4, 5. It'll be between 5 and 6. The median of 79 and 79 would be 79. So I can put that in here. That's quartile 1. And I forgot that should be... Okay, my median was 85. And my quartile 1 was 79. And my quartile 3, I'm going to find that next. So I'm going to start there. 1, 2, 3, 4, 5, 6 would be the median of 90 and 90, which is 90. So I'll locate 90 on here, and it's really getting cramped now. Okay, so those are my quartiles. I'll draw the box. My lowest value of 74, I put on as a dot here. Draw a whisker. My highest value is 93, and that would put me right here. And put a whisker. Okay, so I've got a picture, got my double box plot that I can compare. And overall, looking at this information, because Pisker's box is higher than Arnold's box, it looks like overall Miss Pisker's class made better grades on their project. Alright, so I'm going to say Mrs. Pisker's class made better grades, or made higher grades on the project. And that's it for 8.4b. Again, this will be scanned and posted in Schoology right along with the video. Your assignment will be to complete 8.4b. This is called Practice 2 because they both have the same name. So your assignment for this lesson is to do the Practice 2 page. And that's it. Alright, thank you very much.